Hello and welcome to another supplemental lecture for my class, Experimental Methods, that is PSYC 440640 at North Dakota State University in the spring of 2016. As you can see from the title here, this little lecture will be on simple regression in Excel. And the reason I want to give it is in recent class lectures I've been talking about simple regression, and we'll be getting on to multiple regression soon. And most of the examples that I've given and most of the work that we've done has been in SPSS. And the reason for this is I want to save time in class and not also throw too much information at the students. But I think that learning how to do regression in Excel can be useful for at least a few different reasons. And indeed, in past years, past semesters of teaching, I used to have quite a lot of regression in Excel in class, and I had to kind of cut out and shift things around. So I thought I would use a little bit of supplemental lecture time to cover some material that I used to cover and some new stuff as well. So the way this is going to work is I want to give an introduction to simple regression, and that really is just this. It is cases of regression where we have one predictor variable and one outcome variable. Simple. And to handle simple regression, or indeed to handle other forms of regression like multiple regression, in Excel you have some different options. One is to use any of a number of different functions that Excel has to compute various parameter estimates and other calculations that you would use for a regression analysis. Another option is to use the data analysis Toolpak, which comes built into Excel, but which you actually have to kind of turn on, and I'll show you how to do that. And the third option, which is new, or new to me, and I think actually just legitimately new to the world, is Regressit, which is an add-in like the data analysis Toolpak, but it's been written by a third party, and you have to download it from the internet. The good news is it is free, and the more good news is, or the further good news is, it seems to be able to do some things that are difficult to do with either functions or the data analysis Toolpak, and thus it may be worth a look. I'm certainly looking at it these days and thinking about how I can use it in class or for my own work. Okay, so for this introduction to simple regression, I'm using an example that actually comes from Andy Field's Discovering Statistics with SPSS, and it's a pretty simple example where you kind of imagine that you're a researcher working for some sort of consumer marketing firm, and what you need to do for a job is to predict record sales as a function of advertising budget. And you could imagine a record company has approached you and said, well, we've got this new band, we'd like to get a sense of how much their record sales will be in this coming quarter based on how much advertising we throw at them. And in order to develop a model that would allow you to make such a prediction, you get from the record company a data set that includes the 200 previous bands that they have launched. So how much money was put into each of the advertising budgets for those bands and how much record sales they eventually did. So again, our predictor variable is advertising budget of previous bands. And because the author of the textbook is British, so I guess this is a British example, the variable is in a metric of thousands of pounds of currency. The outcome variable is record sales of these previous bands in thousands of units, whether that's records sold or downloads downloaded or whatever. If you're following along in my class, you can find online in Blackboard a worksheet called record sales, or an Excel dataset, and I actually encourage you to follow along. And if you do, you should see that I've added some comments to various fields in that dataset so as to help kind of highlight or remind you of the different calculations you're doing. Anyway, if you download the file, it looks like this. There are 200 rows corresponding to 200 different data points. Each is a different band. Each has a value for amount of advertising in thousands of pounds and amount of record sales in thousands of units. Kind of looks like this. Of course, with many forms of data analysis, perhaps especially with regression, it's often helpful to first make a graph, in this case a scatter plot, where we look at the relationship between advertising budget and record sales, and you can just kind of eyeball this and see that it looks like there's a positive relationship there. There seems to be a much more variability in the relationship between advertising and sales at the low end of the range on advertising, much less so at the upper end. So that's something to think about for a little bit later on. But generally speaking, you could just imagine drawing a line through that cloud of dots to characterize a kind of a positive relationship. So like I said before, there's some different approaches to actually doing the analyses. I mean, graphics and visualization are important. They're often an important first step to analysis, or they're an important kind of supplemental step. But most of what we want to do with regression, we want to do in terms of some pretty formal testing. And one way to go about that is to use various functions. So Excel has a lot of functions built into it, which you can call up either by typing into the cells or by using the functions key and then searching for the function you want. The disadvantages of this approach, or disadvantage, is that it can be a little bit tricky. You have to know about these functions or be at least a little bit comfortable using them. And in the case of array functions, which I'll talk about in a few more slides, this can be a little bit fussy. It takes a bit of practice to get the hang of it. The advantages are that you learn about statistics when you do this. I think that's important, especially if you're in my class. Hopefully you do too. The other nice thing about kind of hacking out your analyses with functions is that the calculations you make are almost always dynamic, meaning if you go back and change your data set, the calculations will all automatically update. So for instance, you can imagine going through a set of analyses and computing regression coefficients and some sort of an ANOVA with a p-value, and once you've done all that, you look back at your data set and say, oh, there's clearly some bad data points here, some data entry errors where values are incorrect. I'm just going to go back and change those. If you do, all your subsequent calculations will update if you've developed them using functions. And if you're at all confused by what I just said, try it yourself and you'll see. So if we're going to do this thing, if we're going to take this approach of using functions, we're going to use the model comparison approach, which I've talked about in class and which our author Andy Field talks about, and indeed other authors who I tend to like talk about a lot. That is, we're going to compare a compact model to an augmented model for this data set. Now in the case of the compact model, what we're talking about is just a line which is going to pass through that cloud of dots, but that line is going to be flat. It's going to have no slope. And it's going to have an intercept which is equal to the sample mean. So if I want to create or find the values for b sub 0, the intercept, and b sub 1, the slope, it's pretty easy. The former is just the sample mean, which you can see here I've computed in an earlier step that I didn't show you, and I'm just copying it into a different cell so it's labeled as model C b sub 0. Like I said before, the slope of this line for the compact model is flat. It's 0. So that's obvious. You just type 0 in, or just remember that the slope is 0. You don't even really need to type it in. What this 0 represents is the idea that comes from our null hypothesis, that there is no relationship between our predictor variable, advertising budget, and our outcome variable, record sales. So the compact model we can state in terms of just simple language, or we could write it out in terms of notation. That looks like y hat sub I, so the predicted value for each person, is equal to 193.2 plus 0 times whatever their advertising budget is. So again, each case or each band is predicted to have a value of 193.2 times 1,000 units. We kind of ignore that bit for the moment. And that value doesn't change at all as a function of how much advertising they get. So again, if you want to visualize this, it's just a flat line passing through the cloud of dots, and you can see that for some cases, for some data points, this model is pretty good. It crosses or touches some of those data points, and it's close to many of them, but for lots of the rest of the data set, it's not a great description of the data. It's not a great model of the data. Now let's move on to the augmented model. The augmented model is just one one element more complex than the compact model. It is a model which is a line, a straight line, and it has an intercept, but it also has a slope. You know, that slope is a value which suggests that there is some relationship between advertising budget, our predictor variable, and record sales, or units of record sales, or whatever, our outcome variable. Now, it was easy just to find the intercept and the slope in the case of the compact model. It's a little bit trickier to find it in the case of the augmented model, and in fact there are a couple different ways we can do it. One is to use a function called LINEST, linear estimation, which works really well for simple regression, and actually also works well for multiple regression, as do most of the other functions I'm going to mention. And you can see here I've typed in LINEST and a set of arguments in the field down towards the bottom of your screen. What this is going to give us is a value for that intercept and a value for that slope. Now I've actually graphed the augmented model here just so you can have a sense of comparison with what the compact model looked like before, and you can see that it's a really good model for some of the data. It's not such a great model for all of the data. You could probably just from eyeballing this see that it works a little bit better than our compact model would. But the important thing to take on board at this point is that it is a flat, or is a straight line that is not flat. It has an intercept, but it also has a slope. So as I said before, we're using the LINEST function, and LINEST is an array function. Array functions are a whole class of functions within Excel that are characterized by the fact that they look in multiple cells, arrays of cells, that is rows or columns of cells, and they can output values to arrays of cells. And normally what maybe when you think of functions in Excel, like the function for the average of a range of cells, or even something like the standard deviation, what you're imagining is going to a particular cell, typing the equal sign, then typing some sort of a function like equals average, and then giving a range of cells, and Excel just kind of goes through those different cells and computes the average. Array cells work like that, except they often take sets of values in different ranges of cells, different arrays, and then output values to multiple, often adjacent cells. That may sound a little bit tricky, but it's not actually that bad. What we're going to do here when we use LINEST is we're just going to highlight two cells down here near the bottom. I've done that, although it's kind of overwritten by the text, so you can't quite see, but I've highlighted two cells, then I've typed equals, and I've started to type in the function for LINEST and the various arguments that it takes. So again, highlight two cells. We need two cells, we know, because we need a value for v sub 0 and for v sub 1. Then I type in the LINEST function, and I'll get to exactly what all the arguments are. And then critically, once I've done it, I press Ctrl Shift Enter at the same time. That locks in, if you will, the array function, and actually writes those funny little brackets around the sides of it to indicate to you that it's an array function that is looking at ranges of cells and outputting to ranges of cells. So, by the way, how LINEST works: LINEST, the word, is the main function. In parentheses, you enter several different arguments. The first is an argument that corresponds to the outcome variables. In this case, the range is b sub 2 or b2 to b201. That's the column for the outcome variable sales, comma. The next argument is the predictor variable, which is A2 to A201. That's advertising budget. Note, there can be more than one predictor variable. You could have a set of predictor variables if you were doing multiple regression. We're not in this case, we're doing simple regression. You've got your outcome variable, you got your predictors, comma. Next argument is a logical argument, which I'm writing as true. True tells LINEST, or tells Excel when it does LINEST, to calculate an intercept for this line rather than forcing the intercept to be 0. You could, if you typed false, force Excel to make a line which has a slope but which has an intercept which has to equal 0. There are probably a small handful of cases where you'd want to do that. Almost always in the types of analyses that we do in psychology and the behavioral sciences, we don't do that. So almost always you're going to be typing true, comma, and then the last argument is false. It's another logical argument. False tells Excel to not include a bunch of the other regression statistics which it otherwise would if you'd either left that space blank or typed true. We only want b sub 0 and b sub 1. There actually are a few other calculations that Excel wants to give us, but we say false. Don't give that stuff to us. So once you typed out that command, linest, close parentheses, Ctrl Shift Enter, if you do it properly, you'll see two cells next to each other which have two values that you want. And those values are right there in the bottom next to that little label I have called regression. And then what I'm doing is I'm just copying them into some separate cells just so that I have nice, neat labeling for them. And it is the case that the intercept is 134.1 and the slope is about 0.10. So you can see I'm copying them into some different cells. That's not strictly necessary. I just do it for clarity and because I guess I'm a bit obsessive about my labeling. Okay, so now we've got values for the slopes and intercepts of our compact model and our augmented model. Let's go ahead and write out or calculate out the values that each of those models predict for each of the bands in our data set. And this is really easy. All we need to do is go up to a cell, adjacent, or to the column, I should say, adjacent to the column for sales. I'm calling that column Model C. And in that column, I'm going to put the value that that model, Model C, predicts for each of the different bands. And I'm going to calculate that value using the same regression formula that we used before and just plugging in the values for slope and intercept. So in the case of our compact model, we just need to plug in the value for the slope, for the intercept plus the value for the slope, which happens to be 0. You're probably familiar with Excel functions already, but the reason I'm putting these dollar signs in around the value for the slope and the intercept is to freeze them so that once I start copying down from one cell down, those values don't shift. What I'd like to do is write this formula once for my cell C2 and then be able to just say copy paste and copy paste it all the way down. We're just going to go ahead and do the same for the augmented model, and you can see here in this view kind of where these values are. There's the value for the slope, the value for the intercept, and I'm taking for the cell, it happens to be cell D191 here, the value that of the prediction for model A for that particular band is equal to the intercept plus the slope times the value for advertising budget. If you do that, then you end up with predictions that Model C and Model A make for each of your bands. Interestingly, there are other ways to get at this same information. One of these other ways is to use a different function in Excel called the trend function. Trend is another array function that actually works a lot like LINEST, except in this case the arguments are a little bit different. You could go for, you could just highlight a particular cell, write the value equals trend, and then in parentheses write trend, and then outcome variable, predictor variable, a space, and then true. Obviously outcome variable and predictor variable are the same as before. True in this last logical argument is saying calculate the intercept. Normally don't force it to be 0. the interesting thing about the trend function is you can use it to make predictions about new values. So if we wanted to, we could say, based on a trend that you develop from this predictor variable and this outcome variable Excel, why don't you give me the predicted value for a band that has, you know, a certain amount of record sales. You know, we could in a sense skip ahead and just say, for a band that has, you know, 200,000 pounds of advertising, what would their record sales be? In this case here, we're not going to do that, because what we're going to do is instead just create all the predicted values for the augmented model using the trend function. So we're kind of leaving a little blank there where that argument should be. I've kind of indicated that by the word space here in my little notes, although of course you wouldn't type the word space, you just leave a space, or even just don't, just write comma, comma. The interesting thing to note here, or at least it's not really interesting, it should work out this way, is that the predicted value we get from using LINEST, which I've written here in the column under Model A, is the same as the predicted value we get from trend, which I've written here in the column under the heading prediction. So really, again, you could use LINEST, you could use trend, they work almost exactly the same way, at least as I'm doing them right now. Now once you have our predictions from the compact model and the augmented model, you can go ahead and solve for the various sums of squares and for the value of f and proportional reduction of error and the p-value, just as you would any other model comparison that we've done in Excel. And for the purpose of this supplemental lecture, I'm not going to go through and do all that again, because if you're in my class, you know how to do this, or if you don't, you can at least ask me about it, and it's obviously not all that hard. And again, just to put this in perspective, what we're trying to do is compare two models. One model is this line, or could be described as a line for the compact model. It's the flat line. The other could be described as the sloped line for the augmented model. We're asking which one is a better fit to the data. Our test statistic calculation, or the F that we're computing, is a way of comparing those two models. Additionally, our calculation of proportional reduction of error, aka R squared, tells us how much of the variance in the outcome variable is associated with our predictor variable. You know, when we go from our compact model to our augmented model, we add this one predictor variable. We allow advertising budget to have a non-zero slope, or equivalently a non-zero weight, and proportional reduction of error, or R squared, tells us essentially how much of the variance in that outcome variable, record sales, is then associated with that one predictor variable that we've added. Just a few more things to talk about with regards to functions. LINEST, as I said before, allows you to do some additional calculations related to regression. If you want to, you can do this. The only thing is it's a little bit fussy to figure out exactly how many cells you need to highlight for the array function, so I usually skip this step, to be honest. But you can see if you look at my workbook how I've done it. The only difference here is I've added true, or I've changed that value for that last logical argument from false, what it was before, to true. And what I get for that is I get values for the slope and the intercept, which I had before, standard errors for those, as well as a couple other calculations, which you can see down below. The tricky thing, or a kind of a frustrating thing, is they don't come labeled, so you have to actually look up online what those values are, you know, where Excel is putting those different values. The one that's easiest to eyeball here, as you can see, that value of 0.33, that's R squared. R squared always goes in that cell. And knowing that, you would be able to recognize it. Otherwise, you just have to go to the help menu online and say, oh, okay, that's R squared, and some of the other calculations there. There are also a couple other functions which are handy. One is called slope, which, as you would guess, just gives you the slope if you give a range of values for an outcome and a range of values for a predictor. So it is as simple as it looks. You know, you highlight a cell and type equals slope and give it predictors, give it outcomes, and you get a value for a linear slope. And there's another one for intercept that works the same way. Nice thing here is that slope and intercept are not array functions, so they're somewhat easier to use. You don't have to do the whole Control-Shift-Enter thing. Not that array functions are hard, but these are easier. And what might be interesting to try is to calculate them and see that you get the same values as the slope and the intercept that you got from LINEST, the LINEST function before. Okay, so if all of this seems like a bit too much work for you, you may want to consider using a built-in, or I should say an added-in set of tools like the Data Analysis Toolpak. This is already in Excel, although you have to kind of turn it on. The disadvantages here, really the only disadvantage, is that the calculations are static. So unlike calculations which you do with functions, once the Data Analysis Toolpak outputs values to a particular set of cells in your worksheet, those values just stay there. You can change the data, you can delete the data, the values and the calculations don't automatically update. That may be a problem, that may not be a problem. It depends on how much you think you're going to end up fiddling with your data. Arguably, by the time you get to doing your analysis, you should be pretty comfortable with your data and you should not be particularly inclined to make a lot of changes with it. Advantages are that this is very quick and very easy, certainly in comparison to sort of hacking out the analyses using functions. Like I said before, you have to add in, or you have to, in a sense, turn on the Data Analysis Toolpak. So you just go back to the main tab for Excel by clicking that button in the top left. You go to the page here and go down to the very bottom. I've highlighted here Options. Click on that. Options will open up this rather fussy looking options menu. The only thing you really need to pay attention to is at the bottom there's a box for Manage Excel Add-ins. Just click the Go button there and you get yet another menu. These are all the add-ins which are already in Excel, and you can see one of them is called the Analysis Toolpak. Now once you turn this on, it should be on forever in Excel, unless you're working on a university computer which is designed to reset itself. But if you're on your home computer or your laptop, one time and you're good to go. And so just click the box for Analysis Toolpak, hit OK, and then you should see up at the top in your Data tab on the ribbon for Excel a new little button called Analysis Toolpak. Now you can't see it on this picture here because I've cropped the image a little bit, but it'll be on the far right. And if you click on that button, you'll get this menu here which will have a bunch of different basic or fairly basic statistical operations that you might want to do, one of which is regression. So of course just click on that and you get this workspace here, or I guess this menu here, where you input a value for your outcome variable, that's Y. You input a value for your predictor variable, that's X. You can do more than one predictor variable, interestingly, just as you could with LINEST or with trend or slope or intercept. Here we're only using one predictor variable because of course it's simple regression. And you can ask for a few different options, like you can ask for residual plots and line fit plots, normality plots, confidence intervals, etc., etc. I've not, in this particular example, asked for much of that stuff. And then you just have to give it an output range, meaning you have to find somewhere in your worksheet where you want Excel to put all this stuff. So if you see that box there, you can either specify an output range in the one particular worksheet you have, or just say put it to a new sheet, or even to a whole new workbook, depending on how you like to do your analyses. Once you do that, you get quite a bit of output, which should look more or less like the calculations you made by doing the different functions that I described briefly earlier. So you get a R squared, you get a adjusted R squared, you get an ANOVA table to test the comparison of the two models. The significance value is the same there, it just happens to be given in scientific notation because it's so small. You also get a table for the regression coefficients, including the intercept and our predictor variable in terms of their coefficients, and some confidence intervals there as well. Also, those t-tests are just testing whether the values are significantly different from 0, and yeah, so there you go. Now, the last thing I want to talk about is Regressit. Regressit is basically just another add-in like Data Analysis Toolpak. Disadvantages, again, I'm less familiar with Regressit because I've only just recently heard about it and started to use it, is I believe the calculations you get from it are static like the Data Analysis Toolpak ones are, which maybe is a disadvantage. I like dynamic calculations. I just think it's cool. Other people probably don't care as much as I do. Advantages are it's very quick and easy to use. The menus are a little bit more, a little bit better laid out than the ones for Data Analysis Toolpak, so they may feel a little bit more familiar to you if you like to use SPSS. The graphing that it gives you is quite nice. The graphs are a little bit more polished looking than the ones that Excel produces for you, so that's nice too. Clearly that's a selling point for this add-in. And oh, by the way, it's free, so that's good too. You just have to go to regressit.com. I went there recently, and you can see this is fairly new. They're adding some new information fairly quickly. It looks like they're planning to develop a logistic regression feature, which will be nice for logistic regression, and some other cool stuff too. Now you add in Regressit the same way you added in the Data Analysis Toolpak. The only difference is at some point during the process you have to navigate to wherever you downloaded the file to. So if you're like me, you usually download stuff to either your desktop or to your downloads folder if you're in Windows. So if you go through the same process, you click Excel add-ins and then go, you just have to navigate to where it is, and once you find it, it'll be easy for you to use. Indeed, once you find it, it will appear as a separate element in your ribbon. So you can see here I've now got an extra element in my ribbon in Excel called Regressit. That's just Regressit, of course. The only thing that's kind of interesting, I say the only thing that's interesting, one thing that's interesting about Regressit is it sort of wants to treat the values in your worksheet a little bit like a data frame in a more conventional statistical package like SPSS. So what I mean by that is the way SPSS likes to do things is it likes to have a range of values that are all associated with one variable and another range that are associated with another variable. In a spreadsheet like Excel, really the numbers in a column could be from entirely different calculations. Excel doesn't care normally, but for the purposes of regression, of course, it should care, and maybe for that reason Regressit kind of forces you to first create variable names. So what you would do is just highlight the different the different columns you want, in this case the column for advertising and the column for record sales, and click create variable names, and you can just name those variables whatever you want. Once you've done that, you can click on the button for regression and you can create a name for your model. I called it Model A because of course it is the augmented model. You can call it anything you like. I select one of the variables as my dependent, in this case it's sales of course, and I select the other for my independent or predictor variable, that's advertisement of course. And then I have some options here like saving some residuals and creating some graphs and etc. etc. It's pretty similar to what Excel's Data Analysis Toolpak allows you to do. The layout is maybe a little bit easier. There's some stuff that's relevant to time series forecasting, which I'm not even going to talk about right now because it's not relevant to this example. But you can see here I've just selected a few different options, and then what you can't see is towards the bottom there's a button that says Run Specified Regression. If you do that, you get some output that looks basically a lot like the output that we already have. So like the Data Analysis Toolpak, or indeed like kind of hacking out these analyses using functions, we end up with the same values. A nice thing about Regressit is the way the tables are set up is a little bit prettier, I think. maybe a little bit easier to read, I suppose. The graphs are a lot nicer. The graphs that come up for you automatically are quite pretty. So here is a graph of our model, including confidence intervals, reflecting confidence intervals around that intercept here. So that's kind of, nice. Here's a graph for the residual versus predicted value. You get a sense that at the lower end of the prediction range, the bands which had lower levels of predicted sales, there's more variability than at the upper range. So there's probably some slight heterogeneity of variance in our residuals. That's, maybe an issue, maybe not. We want to think about that a little bit. Nice graph for the distribution of residuals, which, as you can see here, looks quite close to normal. That's the sort of hypothetical distribution if they were perfectly normally distributed as compared to their actual distribution. Here's a nice QQ plot, which is basically like a PP plot, or probability plot. The red line is the diagonal reflecting what we would expect to see if the residuals were perfectly normally distributed, and the off-diagonal dots are what the actual residuals are. In such a large data set with 200 data points, it's not too surprising to see that our model is working pretty good, and there really weren't a lot of outliers in the data set, although it's just kind of fake data that the author made up. So anyway, quite nice, quite pretty, quite quick. Those are all good things, I suppose. So again, just to review really quickly, if you want to do simple regression in Excel, it's not hard to do. If you get comfortable with the functions, that's actually pretty fast. I mean, I can do those pretty quickly now. You can too if you practice just a little, especially getting comfortable with those array functions. If you don't like those functions, or if you want to be even faster, Data Analysis Toolpak is just fine. Regressit is cool and seems to have some newer options, especially and maybe in the area of graphing, and maybe even have some new options in development. So I'm actually rather eager to follow what happens to Regressit in the next few months and semesters. Hopefully they'll keep on adding functions, and who knows, maybe in the future I'll be using it a lot more. It's some cool stuff. Anyway, as I always say, thanks for your attention. Brew yourself a cup of tea or a cup of coffee, stimulate the mind, let all this information soak in, and if you have questions, if you're in my class, talk to me, email me. Otherwise, post comments, let me know, and seriously, thanks for your attention, guys. Good luck with your regressions.